In this video, we are going to talk about compound probability. Previously, we talked about basic probability, where we found the probability or the likelihood that one event would happen. Now we're looking at the probability that one or another event happens. So we'll start with a visual representation. So if we consider event A and we consider event B, then we are looking at the probability that A occurs or the probability that B occurs, but not the probability that they both occur. So if you look at a Venn diagram, then the center part where they intersect would be the probability of both happening. But with compound probability, A or B, or is the important word there, we're looking at the probability of A, the probability of B, but not both. So to calculate that probability in a formula, when you have real numbers involved with this, then you're simply finding the probability that A alone occurs plus the probability that B alone occurs. But since we're not including the event of them both occurring, we have to subtract the probability of both of them occurring. So this is where or and you can see the differences here. So the probability of A or B is the highlighted parts of this Venn diagram, whereas the probability of A and B would be the center part where they overlap. For compound probability, where you're finding the probability of A or B, you're simply adding the probability of A plus the probability of B, but you're taking out the probability of them both happening. Okay, if the two events don't overlap, if it's impossible for them to occur at the same time, say, like if you roll a dice, you can't roll a 5 and a 6 at the same time, then you just wouldn't have to subtract anything out. So if the two events cannot overlap, then they are called mutually exclusive. Okay, let's look at a few examples together. So with a fair die, for example 1, what's the probability of rolling a 4 or an even number? Well, the probability of rolling a 4 plus the probability of rolling an even minus the probability of rolling a 4 and an even number. Okay, well, the probability of rolling a 4, if you have a fair die, that means that it has 6 sides, right? So a fair die would have 6 sides. Okay, so the probability of rolling a 4 is 1 in 6 plus the probability of rolling an even number. So even numbers between 1 and 6 are 2, 4, and 6. So that's 3 out of 6. Minus the probability of rolling a 4 and an even. So a 4 and an even number, the only possibility for that is the 4 itself. So the probability of rolling a 4 and even is just the 4 itself, which again is just a 1 in 6 chance. So we would simplify this. So 1/6 minus 1/6 those are going to cancel, and we're left with just 3 out of 6, or 1/2. In other words, we could say that that's a 50% chance. Right? Now let's look at example 2, the probability of rolling a 3 or a 5. All right, well, the probability of rolling a 3 plus the probability of rolling a 5 minus the probability of rolling a 3 and a 5. Okay, so the probability of rolling a 3, there's only a single side that has a 3 out of all 6, so that's 1 in 6. The probability of rolling a 5 is 1 in 6. And then the probability of rolling a 3 and a 5, well, you can't roll a die one time and land on both a 3 and a 5. So this is not possible. So we don't have to subtract anything out. So 1/6 plus 1/6 is 2/6. And if we wanted to simplify that, that would be 1/3, or 33.3%. Okay, and number 6, the probability of rolling a 6 or a multiple of 2. All right, well, let's look at the probability of rolling a 6 plus the probability of, I'm just going to say m of 2 for multiple of 2, minus the probability of 6 and multiple of 2. Okay, the probability of rolling a 6, only one side has the number 6 on it. So to give us a little bit of a different, a few different numbers here, I'm going to do multiples of 3 instead. I'm going to change this question really quickly because that would essentially be the same as what we did in the first example, and I want to give you something different. So let's look at multiples of 3. And I don't want that to look like a plus sign. Okay, so multiples of 3 would be 3 and 6. So there are 2 possibilities out of the 6 sides that have multiples of 3. And then what's the probability that you have a 6 and a multiple of 3? Okay, so 6 is a multiple of 3. So that's a 1 in 6 chance. Right? Because 6 and a multiple of 3, the only way that that's possible out of the faces on a die numbered 1 through 6, the only possibility of rolling a 6 and a multiple of 3 is if you roll a 6 itself. So if we simplify this, again, we have the 1/6 minus 1/6. Those are going to cancel out, and we're left with 2 out of 6, which is 1 out of 3, or 33.3%.